Today I set up an OR gate on a selector switch, and I had it set up on the sensor with the yellow cord, but that sensor is bad. I didn't even know it. Well, the sensor operates the control, but you have no way to remove control. The sensor's locked closed, so there's no actual switching. So it's bad. Bad. What's up, fellas? Jump in here. We got the 3-phase spinning today. Today we broke out the 3-phase motor. Let's get rid of this. Let's get rid of that. So we're gonna have that. Should kick on. Snap. Okay, we got the VFD controlling the motor, and then we got the PLC controlling the VFD. That's what we got going on today. That's what we got going on today. There it is. There it is. So we got the VFD. Hey, Gus. I don't know about Professor, brother. You guys are crazy. So we got the VFD. We got the PLC controlling the VFD, controlling the 3-phase motor. Yeah, you see it, Chunk? You see it, brother? Hey, look at what we got. Hey, we got some new options. We got some new options, Chunk. Look at that. We got new options all along. Hey, we got the look at what we got. Check out what we got, guys. All right, I got it. I got you guys closed in. Okay, so we got 4 different indicator lights, right? We got the potentiometer to speed up the motor. We got a stop switch, start switch, selector switch with an e-stop. And that right there, fellas, that'll get it done. That will get it done. You know, I don't know what. And then we got all the sensors, right? We got all the sensors. So you got all the. So the. How many people in here? 21. Okay. What? I got a question for you guys. What would you call the indicator lights? Would the indicator lights be on the output or the input? Out. You got it, Mr. B. Okay, output. Yeah. So I got 4 outputs right there, right? So I got my outputs, right? Okay. So let's move on to the next part. So there is a potentiometer. Is the potentiometer an output or an input? That's, yeah, exactly. It's an input. So then let's go to the stop switch and the start switch. Input, right? Yep. Stop switch and start switch would be on the input side of the PLC. And then we have a selector switch. That dirty bad boy right there would be on the input side. And then the e-stop would break connection on the input side. So yeah. You know, just that basic stuff. So I got a bunch of oh, hold on, guys. I'm trying to close this screen. Okay, I got a bunch more inputs, and then I got some outputs. But okay, so here's the trick question. Here's a trick question. I'll let you guys know it's a trick question, but I'm sure you guys will know it anyways. So that relay right there, what would that relay, see that relay right there? Would that relay be on the output or the input? Would the relay be on the output or the input? Just in general. Okay. You could put the relay for both. It could be on the input or the output. You can use a relay to put a signal in or to put a signal out. You know what I mean? It's just a relay. It just closes a circuit. So anyways, yeah, it depends, right? Yeah. I'm not trying to get all technical here, but yeah, that's what you guys should know. Okay, so what about that bad boy right there, huh? What's that guy? What's that guy? New to the family. That's the new new to the family. Yeah, Miguel, yeah. A new family member, 24-volt power supply. Yes, sir. And then we doing our regular song and dance. We're doing our regular song and dance with the VFD, you know what I mean? And the 3-phase motor, boys. Same old standard, just running it. You got it. And then we got the big Mager. We got the Mager right there, just in case things get funky and I can't, and I don't know what I did. If I didn't know what I did, I'd have to bust out the Mager, you know what I mean? But I think we're good on this little control setup. All right, so today, hey, so I programmed today for an OR gate, but I'm gonna show you guys something. My sensor's bad, so right now I'm hooked up on this sensor right here. The sensor's not sensing anything, but my motor's still running. This is an inductive sensor. An inductive sensor senses metal. The sensor's bad. So now how can you tell the sensor is bad? Okay. Here's a good one. You guys see that? How can I tell? Proximity sensor, yes. Inductive proximity sensor. It's not sensing any metal. There's a light on it. There is a light on it, but it's not lit up. It's not lit up. So, you in New York? No, I'm in California with a magnet. No, the sensor's bad. And how? So the sensor's bad. It's not even sensing anything, but it's running the motor. It's not sensing anything and it's running the motor. No, this is AC. This is not DC. This is an alternating current sensor. So it's not sensing anything, but it's still running the motor. That means that the sensing is locked closed. We lock closed, bub. We are locked closed. That sensor is bad. It's not sensing anything. Hold on, fellas. Hold on, fellas. Let me cut this little ribbon off. So the sensor's bad. If I got the sensor and I got metal, it should turn off that load right now. It should turn off that load, but it is not. It's not turning it off, or it's not starting it. This bad boy is locked closed. The the closing circuit is locked closed, and it's kind of weird because I think it's a transistor type closing circuit. Work on docks, hanger doors. I see this stuff all the time. Yeah. So the way I'm gonna test it, if it's bad or I gotta figure out what's going on, is I'm just gonna disconnect it. That's it. Troubleshooting 101. Remove the load. If you don't know if it's bad or good, remove the load and then test everything and then see what the difference is, right? You guys understand that? Scorpio, you do, right? You just remove the load. So let's say I'm faulting out on my drive. Let's say my drive is faulting out, right? Let's say my drive is faulting out and I'm like, what the heck's going on, man? You know what I mean? And I'm like, is it the motor? Well, guess what? I'm going to take the motor off the circuit. Then I'm going to turn the drive back on. And then I'm going to see. Oh, guess what? Everything turns on fine until I hook up the motor. Oh, crap. That motor's giving me trouble. Then you push all your investigation towards the motor. You know what I mean? Lean over the shaft with the baggy shirt. Yeah, right? Yeah. Actually, yeah, you're right. It'll get me. That thing will get me. Will a failed sensor trigger a fault code? If I have it, well, right now this sensor will not trigger a fault code. If you want the sensor to trigger a fault code, you have to program a fault code. You know what I mean? And you can't program a fault code with this sensor because this sensor is only open or closed. You know what I mean? Power in, you hit the sensor, and then it closes the circuit. It delivers power to the output or to the controlled output. So what I'm going to do is we're going to test the sensor right now to find out if it's bad or good, but it's definitely not giving any change when I trigger it, right? So it should time out on a timer. So let me do this. So what we're going to do is I'm going to see if the sensor is bad by just disconnecting it. Boom. Look at that. There you go. Troubleshooting 101. That's it. I disconnected the sensor. The whole circuit shut off. That means this sensor is not sensing and normally open or normally closed. This sensor is locked, closed. That's it. What you do is get a magnet. A magnet? I don't have one. Is that how you test? Is that how you test it? If that's true, that's good stuff. I did not know that. Yeah, because you guys were already saying get a magnet. I don't have a magnet, but if that's true, I'm gonna try that. If that's a working theory, I like it. It's with metal, yeah. It's a inductive sensor. Basically, metal will set anything metal within 5 millimeters, because the sensing distance is 5 millimeters. So anything metal will trigger that. Not this one. Yeah, it's an inductive. So it's a proximity sensor. It senses something in the proximity, but it is inductive. Look at. This is a proximity sensor. This is a proximity sensor. And this one is a capacitive proximity sensor. This one is an inductive proximity sensor. This one tests everything. This one only tests metal. Yes, sir. That's it. Everything, wood, skin, beer can, and this one will sense only metal, only aluminum, ferrous metals, steel, you know what I mean? Stainless steel. Just changed one out on a pallet wrapper. Yeah. Hey, I'll tell you what, man. The pallet wrappers, hey, those things suck, man. A beer can, yeah. Tell me the difference between a PNP and a NPN. I could tell you the difference, but I can show you the difference even better. The PNP is a positive, negative, positive. That means it'll have a positive controlled output. And then the NPN is negative, positive, negative. It will have a negative output. Me too on the Lantec. Yeah, the Lantec wrappers, dude, those things suck, bro. You're just testing me? Yeah. PNP 24 volt non-zero. Yeah. So if you're outputting a negative, that means your load, the other side of your load has to be connected to that positive. You're outputting the 0. That means the other side has to have the 24, right? Yes. So, yeah. So this sensor is bad. So if I plug this sensor in, again, it's a normally open. It should be normally open state. It should only engage when I trigger it with metal, right? But it's bad. I didn't even know it was bad. Real spit. I was trying to show you guys something, and then I'm like, hey, what the heck? My whole control setup's turning on. So if I plug it back in, there it goes. See? I guess it kind of works, right? But it's just not, you don't even need to sense nothing. It's just always on. So I guess that's just what we're going to have to deal with tonight. But here's kind of the point of tonight's live. If it works, it right. No, Scorpio. Right? It works. Ground the body of the sensor. You know what? Maybe you're right. Maybe you're right. Maybe you are right, because I did not connect that sensor to ground. You are right. Let me try that. So hold up. Okay. Okay. So I'm going to get another wire. I'm going to get another wire, and we're going to ground the body of that sensor. Who said that? Who said that? Somebody, one of you big brains out there said that. Blue Cousin, shout out to you, my guy. I appreciate that. I'm going to pin this. I'm going to pin the homie right here. Hold up. Let me pin the homie right here. Pin that comment. Ground the body of the sensor. Let's do that. I appreciate you, man. Hey, you. I appreciate you. Mars, the Great said it. Yeah, right. All right, so let's ground that bad boy, huh? We gonna see. Oh, you gonna see. Oh, you gonna see. Oh, you gonna see. All right, guys. I'm not even running ground on this system, but before I do that, let's go ahead and shut the show down. You know what I mean? Let's shut the show down. Can you guys see?
No, that's too much. I can barely do one push-up. How am I supposed to do 100?
Hi! There it goes. Where'd it go? Let me get that, cause oh my god, my wife be finding all these little scraps that I cut. Oh my god, I never hear the end of it. She be finding all the little shreds. Oh man. All right, so let's ground it. So here we go. We got that bad boy, right? Shove them up in there. And let's hit that ground. Okay.
100 push-ups and 100 sit-ups. What's next?
Now in the last section, you train your stand-up.
Great job. I'm impressed.
So, is there anything else?
Okay.
Run for your life.
I'm moving all the metal away from the sensor. Yeah, it still turned it on though. Ah. Yes, it's bad, bro. That sensor is bad. I have grounded the body and it's still bad. Can you show us your connections? Yeah, I'll show you the connections. All right. Oh, okay. So let's go here. So we have, see this red and black wire that I have running into this blue wire with the white stripe? I'm gonna follow it to the other side, okay? That is straight to the AC power. That's your hot, ungrounded conductor, right? And this, hold up, let me show you guys a little bit better. This wire right here, this red and white, goes in with that yellow, right? And then the yellow goes into the PLC input. Input number 2. See how input number 2 is lit up right now? That's what the PLC is being driven off of. That is what the PLC is being driven off of. Input number 2. Now, you guys want to see what input number 1 is? I'm only using input number 1 and input number 2. Look at what input number 1 is. My selector switch. Watch what happens when I turn on my selector switch. Now look it. You're showing 2 inputs because I'm running off my selector switch, which would typically be your manual, right? Your manual or yeah, like a manual mode. And then your input number 2, right? Let me turn that off. Your input number 2 would be your sensor. So that would be like your automatic mode. Like every time it senses, it does output, some kind of an output. Well, so there's really no testing on the sensor because it's just basically power in, ground, and output. You know what I mean? That's it. It's not like it's just a like a 2-wire sensor. So yeah, I know it's bad. It's bad. So if I wanted to do this, I'm gonna disconnect my sensor. Done, right?
So you actually do like the children.
And
He stole a chair.
It's kind of funny, not gonna lie.
I turn it on with my selector switch.
You play too many games.
Done. So there it is. Now we're running off of output number 1. Yeah, the sensor is AC. Stop the motor and see if it stays on. Stop the motor.
Yeah, he's in a meeting with God now explaining his death. And he is like, you are too stupid for having
Yeah, Scorpio. I see. It's 2-wire now. Force the bit. Oh yeah, I could force the bit. I could force the bit. So now that we are disconnected 1000%. So here is my input. Here's my input wire for input number 2. So if I turn my power off now, let me hold that down. Here's the question. Here's the question. I'm going to force the bit right now. Opening like an hour off. So here's the question. On this PLC, what is it? What is the input power requirement? What is the input voltage requirement? This PLC has to have the, no, not 5 volt. This is 120 volt, no, not 240, 120 volt input. That's what you have to run to the input. You have to put in 120 volt from the same power source as line 1 of that's powering the PLC. I would prefer to use the same power, what is it called, the system. I would prefer to power the PLC and run the inputs off of the same system. Now some PLCs will use the 0 volt, like the syncing and sourcing, right? So 100 to 240 volt. Yeah, it's possibly that 1 to 240 volt. So that's what the input is. So see the yellow wire right there? That is the input.
Just look at his crazy smile. Plus he's being followed.
Yes, we'll do that right now. So let's get my
Now he's crying like a
meter, right? And we will test
The big bro is so dead.
the sensor. So we have the 3 pins right here, right? So we're in continuity on the meter.
Then you'd be spoiled like him. I don't care. Max, can I please punch him? I think you're a bit too
And the sensor has 3 pins. The pin, okay, the pin right here, in between these 2 gaps, see that sleeve and that sleeve, that is pin number 3. And if that's pin number 3, that's pin number 2, and this pin is ground. That pin is ground right there. So we're going to test pin number 3 to pin number 2 and see if we have continuity. You should not have continuity. Only when it is sensing, you should get the continuity, right?
because you're gonna need it.
I think the controller, I don't think this controller could do PIDs. I haven't checked yet. It has a long manual, dude. I've been reading the manual and working through the manual, and it has a pretty big manual. So let's see that. So none of these pins should have continuity between them. That's basically it. So let me sit down where I could get comfortable. Can you guys see? Hold up. I want you guys to see the meter if you can. Ay, 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 boys. Okay, hold up. First, let's do this. I'm gonna go ahead and get greedy on you guys. We've been on here for like 30 minutes. Can we get some likes though? Can we get to 1,000 likes? That's all I'm asking. For now. All right, check it out. Let's see. We got. There it is. There it is. Continuity between pin number 3.
That was hilarious. I can't. Did you hear his scream?
I know, right?
Hold
It was
up.
my first time hearing him cry like a sheep.
And just like that, you're
Uh-oh.
down to your last half. And you survive.
Okay, hold up.
And get smashed
Yeah.
by 100 eggs and take the lava bath.
Where was that sheep?
Oh, you know what? Let's do it like this.
Oh no, that's so fun.
What a knucklehead, huh?
Just imagine seeing a poop face in the middle of the night. Shut up.
Let me plug it in. And then we'll do it from the connector. Because I'm not even going to be using that bad boy no more.
That was the craziest fall I've ever seen. That's just skill issues, though. I would never fall down running around a pool. Bullying is just the worst.
Alright. We'll do it from the connector. So we're going to lock one up in there. Right? And we'll test this.
Teacher protecting his student.
So it's not showing anything.
Poor kid.
Wait, what? How quick the dude realized not to mess with him.
I know, right? Just look at his big and scary eyes.
Noob versus
It is not showing continuity now. So let's see between
points to 0.
these two.
That's so cool.
Okay. They're not showing anything.
I wish I could do that too.
It's not showing anything now. So why, when I power it, it's like a closed circuit, and we're not controlling through the sensor.
Yeah, he looks kind of like an eagle now.
So this is the ground.
Wow, just ate everybody's food.
Okay.
And he's still hungry?
Oh my god.
Okay.
He's becoming a monster.
You mean
Oh, yeah.
now they're shooting?
Damn, see? It turned right on. It's not controlling, but it also not showing continuity. Damn, 2000? Good looking out, boys. It's not... I don't have a magnet. Let me see. Where do I have a magnet? I have these guys. Bam! Does that count as a magnet? I don't know if it's strong enough, but let's check it out. Like that? I don't think this little magnet's strong enough. He not do nothing, boys. He not do nothing. Nothing, boys. Nothing. But I got these nice, cute little 8s. I got these on TikTok Shop. If you guys want to get your hands on some of these little 8s, you could go to my TikTok Shop. Put it to the relay. Yeah, he's not doing nothing. Okay, hold up. So, let's test the sensor with no input, no PLC. Okay, we're gonna figure out right now if this boy is bad. So the point is, shut the motor off. Well, if I shut the motor off, I have to turn off the VFD. There. The motor's off. The motor's off. The VFD is off. But the PLC is still showing output number 2. Right? Output number 2. You guys see it? Output number 2. Test the voltage of the sensor. The voltage of the sensor is grounded. Yeah, it's a sensor grounded the same place as the motor. The motor is not grounded. The motor is not grounded, but we could do that. The motor is not grounded because it's operating off of the VFD, and the VFD is not grounded. So let's go ahead and ground the VFD. We will ground the VFD, right? So we could do that. Let's go ahead and do that. So I'm going to have to shift over to a blue grounding lead. Right? Zoom out. Yeah. There we go. And then here is the ground coming out of our inverter. See, we're not running off of our wall power. We're not running off of the wall power. We are running off of we're running off the inverter. I am not trying to make the logic. I'm just basically doing an OR gate. So it's selector switch or the sensor. That's what we're doing. Selector switch or the sensor. And the problem is our sensor is not sensing. It's only turning the motor on and leaving it on. It's no sensing ability at all. So now we gonna
I can imagine you having a panic attack, so I choose that one.
we're gonna use that as the ground. So we'll hit the ground in there. We'll hit the ground in there. All right. So now, let's ground this guy to our motor. Right. Let's find a good little spot on our motor to ground to. You guys want to see? You guys want to see? So I'm basically going to hook up my grounding wire in the motor. on the grounding terminal. All right, one screw. Opening the pecker head right now, so I can hit that grounding screw in there. You know what I'm saying? I don't want to lose these screws. Brat, brat. Pull out my wiring, find my grounding terminal, there it is, and there it is. Okay, move that. Oh.
At the end, the nightmare continued. So technically, you didn't win. Well, technically, she has 3 points and you have 2.
We got 67 points. What a coincidence.
You see that scared of the 6-7 meme?
Life follows him everywhere.
Like and subscribe if you think dear.
Okay, there we go. We are grounded in the motor, all right? Whoever just followed, I appreciate that. Okay, so we are grounded in the motor. So let me go ahead and plug them back in. Turn my switch off. Power up. So my VFD came on. I already tried switching the wires around, but we'll do that again. And then, as soon as my logic kicks in on the screen, it's gonna turn on.
Yes, sir.
There it is. See, without even touching or sensing. Yeah, that sensor is bad. It is bad, but I'm not getting a reading on the multimeter for continuity. That's kind of weird. I don't know what that why that is, but I could try switching the wires. So put it this way: we grounded on the motor, we grounded on everything else, and grounded on the sensor. So now let's try switching the wires. Okay. All right, so there we are. You guys, as soon as I disconnect this wire, it's going to turn off. Listen. Off. See it turned off? And now we're going to put this wire into there. Put that wire into there, right? And I got to be careful because it's outputting 120 volts right now. Oh, it didn't lock in. He's outputting 120 right now. So it may shock me, may not. I'm not grounded. There it is. So we have switched the wires and it's still running, but there's metal. Not sensing, boys. Boo! Sensor's trash. That sensor's trash. Lockout deck. Yeah, right? Hey, I didn't bring my whole lockout kit. Alright, you guys still there? Okay. Accidentally shut the phone down, boys. Yeah, I forgot my lockout kit. Don't touch the sensor with the pliers. Just run it back and forth really fast. Creates a signal. Alright. Alright. Ready? See it? Nothing, fellas. Nothing. So we are dead in the water with that inductive sensor. But that's okay. Are you using the right type of sensor that detects metal? Yes, inductive sensor. So is the sensor supposed to be normally closed? No, it's normally open. But it's just closed. It's not normal. It's just closed. It is not being normal at all. The sensor is PNP or NPN. Matters on the input wiring. This sensor is... I'll pull it up.
Oh, yeah, baby.
That's the sensor right there. 1, 2, 3 pins, right? Pin number 3 and pin number 2 do all the business. Whether it was normally closed or normally open, it should operate in the state that it's in. So there it is. We have 120 going to L1, and then we have L2, which is the load which is the input of the PLC, and then terminal 1 is just our ground. That's the one we're running the ground on. Yeah, fellas. So what can we do? On this case, for this machine, put it this way. For this machine, if you want to turn off the sensor, you have to... Okay, we could do that. We could do that. Your name is... You just have a little line for your name. Okay, so you say switch L1 and L2 back, and then run the pliers back and forth again. Yes. So let's turn off the power. Everything's gonna shut down, right? And let's go ahead and do it again. Let's go ahead and do it again. I'm gonna be honest with you guys. I did not know that sensor was bad. I did not know that sensor was bad. It kind of threw me off when I hooked it up. I was like, what the heck? What the heck? So here is either L1 or L2. I got to look at it to be specific. But he say, let's switch it. So we're going to put this wire running with the yellow wire, right? With the input of the PLC. That is our input, our PLC input. So we're going to go ahead and swap these guys. There it is. Gotcha. And now we'll put this guy with this guy, right? And we're gonna go ahead and do the little test again. Is the logic even working? Okay, I'm gonna test that next for you. Hold up. I'm gonna pin that comment. Okay. So let's go ahead and power back up. All right. Man, I'm getting thirsty, boys. Always go to the logic first. Okay, we could do that. We could do that. We could do that. Okay. So right now, we're running off of terminal number 2. You guys can see input number 2, which is up here is the yellow wire. Input number 2. Input number 2. And you see we're illuminated on input 2. Okay. So first I'm going to do what the line guy, the guy who had the name that's a line, said. He said to hook it back up with the wires reversed, right? And then try this again over the pliers. So without touching. Nothing. That sensor is locked, closed. Okay. So now, okay, we're going to do that. All right, so let's check the logic. Okay. All right, so how do we check the logic? What is one quick but fast? Oh, but fast? Okay. Ready? That is. Okay. The wiring diagram? No, those are it. That's pin 1 and 2. We already did that. Alright, so now let's check the logic. Sensor is cooked. There you go. Sensor is cooked. Now I get that. But it's okay. You know why? We're just verifying that it's cooked. We're going through all the methods and the ways to verify that is bad. You know what I mean? So if you guys want to stop the machine, this is what you got to do on the line. Whenever you guys want to stop the machine, you got to unplug it. And then it'll stop. And when you guys want to start the machine again, plug it back in. There we go. Is the back stud, is the back black stud on the sensor head metallic? No, this is plastic. Plastic. Okay, so now let's check the logic, right? Let's check the logic. Okay. Who had said check the logic? It's not adjustable. It's only a 5mm sensing range, and that is it. The black mark head should be blue. It's black and blue. That means it got beat. It got beat. It's black and blue, boys. I think this thing is toast, bruh. Toasted. I know why it's blue. The blue is paint, because that's the machine that it came off of. The machine it came off of. I don't think it's going to sense the paint because it's an inductive sensor. It only senses the metal. Let's try that. It should only sense metal. What are the amps on the sensor? It's going to be milliamps. I think it's 250 milliamps. So I think that would be like a quarter amp. Yeah, this thing is toast. Okay, so let's check the logic. Who said check the logic? One of you guys, actually a couple of you guys said check the logic. What's the goal here? Maybe put another sensor, but we got 2 inputs. We're running on 2 inputs. That motor, probably about $200 to $300. The sensor I put on the PLC. The sensor detects. We already checked the logic. You unplugged it. Right, but let's check the logic. Let's check the logic. So the quickest way that I would check the logic, since I'm only operating off of input 1 and input 2, I would swap input 1 with input 2. Does that make sense? Is that how you guys would do it? Swap input 1 with input 2, since they're giving the same 120 volt signal? Is that how I should do it? Is that how I should check the logic? There's only one way to engage the input. There's only one way. It's if it stays on, the sensor is toast. Yes. Oh yeah. Oh, they're giving the same weight. Doesn't matter. So here we go. Let's check the logic. Okay, I'm gonna zoom you guys in. Right? Can you guys see that? So you guys can see the input and you can see the logic screen, right? Let me see. Input and logic screen. Alright, I think you guys got it, right? So right now we're operating off of input 2. Logic screen, input number 2. So let's go ahead and swap that. So I'm going to pull this wire out, which is going to be live wire. Let me pull this one out first, since this one is not live. Right? Bial. Right? And then we're going to pull this out. This one is to the sensor. This is going to the sensor. Oh, shut down. Input 1, and we start it up again. Now we have swapped the inputs. So now we're operating on only input 1. I think it's supposed to be wired in parallel, not in series. In parallel. How would I wire it in parallel? That is a okay, hold up. So that is it. That is a series wiring. There's no parallel about that. 2-wire, micro connector, normally open. Yeah, the other ones are 4-wire. It's not a 4-wire connector. It's a 3-wire connector. One of them is ground, and then the top 2 are your L1 and your L2. So now that we got the sensor, we could go ahead and disconnect the sensor, right? And we know that'll shut it off. That will shut it off. And now we'll just operate off of our selector switch. Selector switch. Still waiting to see the logic. Oh, you want to see the logic? Okay. Okay. You want to see the logic? Okay. You want to see the logic? All right, let me turn it off. Let me disconnect the motor circuit. Power him back up. Oh. All right. Oh. So here we go. Okay, let me turn off this switch. All right, so now we have no inputs. So we want to, so let's go here. Escape. We will stop the program. And then we will escape. Okay, program. Let's see. Okay, let me show you guys. Let me see if I could go back into start. No, not the clock. Back into start. There we go. Analog, analog, analog. Hold up, boys. Go back. Let's see, is it up? Where the heck is it at? Okay. Damn, where's it at? I'm trying to find the logic block that we have programmed right now. Hold up. Where the hell is that? Maybe, okay, hold on. Maybe I need an input. Okay, I'll show you. Okay. 2 is on. Yes. That's because I have the selector switch turned on. Okay, I can show you guys. Let me stop it. Biome. Okay. Now I'll show you the program. Edit. Edit. There. That's the logic. Input 1 and input 2. And there is an OR gate right there to output 1. And that is my block 1. That is the logic. That is it. And I have an open window right now, so I can change it. But I don't want to do that. So that is it. Input 1 or input 2 to output 1. And that is my first block. And that's what that's telling me. So that's how we're operating. So we're gonna exit, 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 and I'm gonna go ahead and start the program because I had disabled it. Turn it off and on, looking at the screen. Okay. Okay, hold up, hold up, hold up. Bam, 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 bam. Up, yeah. So we're in program, right? I'm gonna enter, edit, enter, edit program, enter, and now we're in the logic. We are in the logic gate. This is basically telling me that right now we're operating on anything in the function block B1 is on my output, right? So let me step back. So there's my logic block. That's telling me. Now you saying to turn off the power in my logic window? Fuck it. There it is. Now let's bring it back up. Let's bring it back up. There we are. Now we're in the program. Let's go back to the logic block, right? Bam. Edit. Edit program. We're back in B1 output 1. And there we go. Same logic block. Input 1 and input 2 are active. Input 3 and input 4 are on standby. I have nothing programmed to them, but I could program them. Let's see. The input switch number 2. Okay, hold on. Let's program switch it on and off. I already did that. So let's do this. You guys want to program input 3 also? We could also program input 3 to output 1. So it'll give us 4 inputs to 1 output. Not the toggle switch. Yeah, I could do let's do input 3. We could make input 3 like a jog. Doof, doof, doof. You know what I mean? Just a little jog. Yeah, we could do input 3 and we can make input 3 like a jog. But since we're not even going to be using this sensor because it's bad, we can make input 1 or input 2 the jog, right? What do you guys say? What do we do? Do we program in input 3? Let's program in input 3. I want input 3 to be a controlled output on this block. So I'm going to go ahead and enter that. And then I'm going to enter, it's telling me input 1. I'm going to make that input 3, enter. Now we got input 1, input 2, and input 3. Or, input 1 or input 2 or input 3 to output 1. Escape, 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 and let's go ahead and start that program. Did you guys catch that? Bam. So right now we're operating off of input 2. Why are we operating off of input 2? Because this red wire goes all the way down to our selector switch. So now input 2 is off. Orale, orale. Okay. Did you guys catch that? You guys catch that? All right. Let's go ahead and slap it back in. let's fire up the VFD. Fire up the VFD. And it should run. The VFD should run when I hit my selector switch on. Done. See that? All right. So that's it. You guys wanted to see the logic. I showed you the logic and I added input 3 as an input. So now we're operating off of input 2. So if I move input 2 to input 3, we should operate just the same. So I'm going to pull input 2. Now I'm going to hook it up to input 3. And there it is. We're operating the same exact way on input 3. Yes, sir. So now if we were to turn off the selector switch, we're shutting off input 3. So we could turn on the motor, full power, and there it is. That motor's running off the hook. I think one of these sensor wires needs to be between the load and the rest of the wire. Well, that's what it is right now. Both wires are between the load and the power. It's basically acting like a light switch. That's basically it. It's acting exactly like a light switch. You have power going into one terminal, you flip the switch, and then its switch leg goes out to the input on the PLC. No, but the sensor is bad. The sensor is like a broken light switch. It's just closed. The sensor is acting like a light switch. You have power here on L1. You make a sensing, and then it goes to the load. Because there's no positive and negative. So if your load was, okay, let's try this. Let's try this. I see something right now. It's acting like a light switch. Yeah, it's just like a light switch. Let me look up. Okay. Hold up. Hold up. Light switch logic. Let me see. Let me see. Okay, hold on. Line diagram of a light switch. Yeah, that's basically it. But this would be the sensor that would switch the switch on and off. But we don't have a neutral. We didn't need a neutral. You're only acting on this. Because this sensor does not require a neutral. Now the load would need the neutral, but we're only signaling an input on a PLC. So I think I lost my let me find my screenshots. Hold up. Right here. And this is the wiring for the wiring harness. Red and black, red and white. What's up, son? So hit those like buttons. Okay, so that was a lot of talking and a lot of movement, and we got absolutely nowhere. We have proven, all we have proven is that this sensor is not acting as it should. So what voltage is the motor? The motor is 230 volts. The motor is a 3-phase 230 volt motor. So yeah, I think that is troubleshooting in a nutshell. If you were to try to prove a point, you would go the long. So it's a 3-wire sensor. It's a 2-wire sensor plus a ground. So that is troubleshooting in a nutshell. You go through a bunch of crap to end up in the same place, but we know it's bad. Now we know it's bad. You know what I mean? I think that's the way it is for everybody. If it's not like that for you guys, let me know, because it's definitely like that for me. I try a bunch of stuff, and then you don't exactly stumble into a bad part. You kind of choose a educated approach, right? And then you find what's bad by using your tools, your meter, and stuff like that. So right now we used a bunch of methods in order to prove this sensor bad. I originally didn't know it was bad, but in the field you wouldn't even spend that much time on that unless you didn't have another sensor. But if you had another sensor, you would just plug in another sensor right away and prove it's bad. You know what I mean? That would be the easiest, fastest way to troubleshoot. Kind of the way we did it tonight was like the long way around it, but I was doing it because I was doing it for you guys. You know what I mean? Just to play around. Let's see what happens. You know what I'm saying? But that was the long way around it, just to prove that this sensor is bad. Typically, we just swap this bad boy out and let's roll. You know what I mean? Yes, sir. Yes, sir. User 110, what's up, Bubba? Shout out. Shout out. Let me get you guys hear that VFD? That VFD fan is cooking. Yeah, that was crazy, huh, Gus? Just to prove one sensor bad, but we ain't done yet. We are not done yet. So I still got battery, so let's run it. I still got battery on this phone, so let's run it. So let's hook up. So let's get rid of this sensor, and let's get rid of this whip. Right? So let me go ahead and shut this bad boy down. No power to nothing. Let's disconnect that sensor. Right? And that is on the yellow cable. Right? So we're going to get rid of that sensor and everything that sensor is about. Get rid of it. Gone. So now we're going to wire in a jog function. We could wire in a jog function really quick. VFD 60 hertz on the motor. No, right now I'm running 50 hertz. It's at 50 hertz right now. But that VFD, the VFD will go up to 160 hertz or like 120 hertz. Man, that thing will get up there. So now that we disconnected the sensor, we could go ahead and kick our motor back on. Bam, 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 bam. Should go back on right now. There it goes. Yeah, it's 120 hertz. So we have troubleshooted that bad sensor. So let's go ahead and wire in our jog button to input 1. Input 1. What's up, Rude Dog? You in the house? All right, input 1. So let's take the old wires that we want. Right? Here we go. Oh man, come on. What the heck? Oh, here we go. Okay. Here we got it, boys. So all our wires really don't make sense until I get some more wire, but I need some like MTW cable. Should be 60 hertz. It will go up to 60 hertz, yeah, but I have it running at 50 right now. All right, so let's wire in this jog switch. Let's wire in this jog switch really quickly. And for that, I need to get a little tool. And we go do it with this tool right here. Bam, this is how I get behind my standoff for this little PLC trainer. You guys can get this PLC trainer. It is very cheap. Very, very cheap to get this PLC trainer. I made it myself out of literally trash. And somebody left a comment in the last live that I was in the other day. And they said, hey, that PLC trainer is trash. And I said, you're absolutely right. It is trash. Everything on there is basically from the trash. You know what I mean? So, I don't know if they meant they didn't like it. but that is fine with me. They said, your PLC trainer is trash. And I said, you're absolutely right. It doesn't have to be. Haters is good, right? Hey, haters is engagement. I'm not even mad. You know why? Because there is a lot of people out there that are asking about the trainer and how do they get their hands on one. So I'm basically showing them it serves its purpose 1000%. Right now we have programmed an actual circuit that is widely used in manufacturing. It does not matter if the PLC is like a $2,000 PLC or a $20, $40 PLC. The logic is the same. The program is the same. The selector switch, the E-stop, the start-stop, the function of your operators is the same. All the logic is the same. Your voltage, it's the same. So I don't understand. Me personally, it's confusing to me. Now, if you were programming language, okay. Now, if you guys were using a programming language in Siemens, in Allen Bradley, you guys were using protocols, that's different. You know what I mean? But for just having input-output functions, I'm more than willing to use trash. Straight up. Clip the Wago going to the potentiometer. Clip? You want me to clip it? Oh, that one's not being used. Yeah, you seen that? Damn, you got an eye. It's not being used though. I only have 2 wires right there, and the third terminal was open. But damn, hey, you caught that, Carlito? That's crazy, dog. Hey, you got a Hawkeye, bro. That is wild. Yeah, that's pretty good. I can't see that. Oh yeah, maybe if I zoom in, you guys can see it, right? Yeah. So, anyways. Yeah, so somebody was saying the trainer is trash, right? I mean, it looks a little bit crazy because all the wiring. But every day before I go on live, okay? I'm telling you guys, every day I tear it down to the bare nuts and bolts, right? I get rid of all the wiring, and I pull off everything. I terminate the program, wipe it, and when I'm gonna set up for a live, I say, hey, maybe, you know, what function do I want it to do today? You know what I mean? But usually before I do a live, I'll do a video. So my last video was 1 input, 1 output, right? 1 single input, 1 single output. And then I showed you guys how to program that in this PLC. Tonight we're doing a little bit, it's not more advanced, it's just different. We're using a gate function instead of just input output, you know what I mean? So we're using an OR gate, which means you can have input 1 or input 2 or input 3. That's it. All 3 inputs go to 1 output. That means you could hook up a switch to all 3 of those inputs and it will start the motor that is on output 1. If you guys don't understand that, let me know, and I may do a video on I'll have to summarize it and do a video just on explaining that, because a lot of people don't know the correlation between an input and an output. You could hook up all 8, yes, I can hook up all 8 inputs. It will take 2 blocks of function. It'll take 2 blocks instead of just 1 block, but I can hook up all 8 inputs to 1 output. That'd be some crazy work. Like float switches, sensors, jog, selectors, all that. Yeah. Can you use a memory bit in this PLC? I don't know yet. I haven't got that far with this PLC. I'm telling you, the manual is long. I spent a lot of time reading the manual and learning, just finding where all the inputs are, just to navigate the menu. So I'm putting in the time. Hey, thank you, user 64. So I'm putting in the time. So hit that like button. You know what I'm saying? Let's see if we could get to 5,000. So I have read the manual through and through. I've been going through it just to find out where everything's at in that PLC, right? So that I could put it. It has timer, and you still have timers. Yeah, timers and counters. We have not even. Oh my God, it's tremendous the amount of things you can do with that one little PLC. That little PLC is capable of more than I'll ever have to do. I'm not an engineer. I'm just a guy who they call for a job, maybe this, maybe that, and they say, fix it, because we don't know anybody else who can fix it. You know what I mean? They don't have your guys' number. If the company had your guys' number, they'd call you. You know what I mean? But right now they have my number, so they call me. So yeah, what I miss? You didn't miss nothing. We're wiring the PLC, but I'm explaining to you guys that this little PLC can do 8 out of 10 any basic stuff that we would have to do. Now, if you are communicating protocols through a huge system, Well, that is a whole different get down. You know what I mean? And I'm sure you guys know that. I'm sure you guys know that. Yeah, that's an entirely different get down. But yeah, so let's go ahead and program in our jog switch. So we will have a jog switch and a manual selector switch, and then we'll think about putting in one of these DC. I have two DC sensors, but we gotta wire in the power supply. So let's go ahead and try to do that, right? Bam. So let's get our jog switch wired in first. Shout out to all you guys who are always here over and over and over again. I see a lot of the same people in here, and you guys are like, you guys are ready to get it. You know what I mean? We're right here getting it. We're doing it live. We're not playing around. So let's do this jog switch. But hit that like button, tap that screen, whatever that looks like. Let's get those hearts up, boys. Let's see what this looks like. Let's go. All right, so we're gonna get this jog switch wired in. Let me power this bad boy down. Brat. Shoot him. Shut him down, boys. Shut him down. All right. So let me pull this off the table, right? And we will get. Oh, we're running out of space around here. Let's get this jog switch wired in. Hold on. Let me do this. Come on, baby. Ah. All right. Had to get it unlocked. It was a little tight. Let's get this jog switch wired in. Okay. So I got a normally open contact block, right? And I want to wire this jog switch or this normally open contact block to my PLC. Okay? Okay, here we go. So we got, let's put our yellow, okay, let's put our blue to the top. Bam, got that bad boy in there. Okay. Now let me tighten it up. Hold up. Sorry guys, taking. Alright, so that one's in. Now let's get the yellow, and we'll make the yellow for the bottom terminal. Right? Hold on, let me flip that down. It's a little tight to get in here. All right, got that. We give that a little snug. All right, so that is in. So we got our jog switch. Bam, okay. So our jog switch is Are you guys there? All right, you guys there? Cool. Brat, what our jog switch is, our yellow and our blue wire. So the jog switch is our yellow and our blue wire. Okay. So where would these wires go? Can you guys tell me that? Where would one or the other wire go? Does anybody know? Can anybody help out with, if I wanted to wire in the jog switch to the PLC, where would one of these wires go? It's not a trick question. It's just a basic question. What do I need to do to get power to one of those terminals? One goes off the power and one goes in the input. Damn it. Oh my God. That's exactly right. In between the start. Yes. 1000% user 110. One to the L plus and one. Damn it. You guys. Oh my God. You guys are good. Okay. Yeah. Make it very easy. It looks like you guys already know exactly what the hell needs to happen, boys. So I got the power off. So let's go ahead and use that input terminal right there. Oh, this is solid. This is like solid 18 gauge ballast wire. It's pretty strong. There it is. Got it. So so this is my power, or it would be my L1, like you guys said, my L1. And here is my wire that's going to go to my input. So we'll turn our selector switch off. And let's see if it works. Let's see. Nice. I do the tug test right there, right? We're going to flip that bad boy back on. And let's see what happens, fellas. Measure the motor. Always the motor, right? Measure the motor, yeah, right? Okay, so we have power. We have power. But I don't see any inputs on the PLC being read. So, what did we just wire in? We just wired in our jog button. Now let's see if we did it right. I guess if I push this button, it should start the motor. So let's start with the selector. Bam. So we got our selector switch on, right? So let's turn the selector off. And now we're going to jog it. Boom. Boom. So now we have a jog button. Now we have a jog button that is operating the motor as well as a selector switch, always on, or in other words called a manual switch, a manual function, right? If you guys have a better name for it, you let me know. What is it called? A manual? Is it called a manual? An on? Should we call it the on? The jog is the jog. So usually when you wire in a jog switch, you would have an on switch and a jog switch. Momentary push button. Yeah, it's a momentary push button, but the function is we wired it as a jog switch. So it's a momentary jog. You know what I mean? A lot of machines that I work on have a jog switch, so you could kind of jog, hand. Bam! Oh my God, you guys are making me, oh man. Hand and auto, right? Hand and auto. So right now we would have on. So our selector switch would be our on. And our jog switch would just be our jog. But yeah, we could call it hand off auto. Hand off auto would be if I had a 3-position selector switch. That is only a 2-position. Oh. That is only a 2-position selector switch. But anyways, we'll go ahead and cycle that bad boy on, and let's work on getting this who is that? Guisi? But let's work on getting a sensor wired in, right? So if we want to wire in a sensor that is 24 volts, I don't even know if I have enough wire for that. I know I don't have enough terminals on that on my little DIN rail right here. I'm gonna have to hook up more terminals because I'm maxed out right now, boys. I am maxed out on terminals. There we go. Okay. So we tried to wire in this sensor tonight, and this sensor is trash. Absolute trash. This thing was dead on arrival. No worky whatsoever. It is locked closed. So we're going to try to wire in another sensor, but I'm wondering if I got time for that. Hold up, fellas. Yeah, so I don't know if we got time for that. Let me turn it off. And let me go ahead and get this guy into here. Okay. Got that one in. Let's go ahead and get this guy into here. Okay. So this will be our neutral. Okay. So now we got supposedly we got our power supply wired in now. Supposedly our power supply is wired in. 4,000 likes, good looking out. I'm proximity sensor. Hold up. Oh, hold on. Sorry guys. Bam. Oh. Alright, let's see. We need to see that guy light up. Bam! Look at that. We got power to our power supply. Oh, crap. We're kicking on, boys. We're kicking on. We are cycling on. Okay. So we now have power to our power supply. We now have power to our power supply. And we are operating right now off of, hold up, input number 3. We're operating off of input number 3. So now let's see what it's going to take to get our capacitive sensor running. Alright fellas, I got all the paperwork. This is your guys' entire arrest history. I got all your files, boys. I got all your files. All your arrest history, I have it right here in my hands. I'm just playing with you guys. So let's find our sensor. So let's find our sensor. So what is this guy? So there's our sensor wiring. So there's the sensor wiring right there, boys. Rap sheet. Yeah, we killed it. Hey, what's up, Miguel? Yeah, so there's the sensor wiring. What does that symbol right here mean? What does that symbol right there? Ah, hold on. G-we-see. G-we-see. I don't know if that's how you spell your name. Normally closed. Yeah, you got it, son. Yeah, you guys are good, man. You guys, I'm telling you, man. I don't know what you guys are doing in my life. You guys should be opening up your own life. That is positive, negative, negative. So that is negative, positive, negative. And you're right, G-Weesey. NPN, boy. Man, you knew it right when you seen it, huh? You knew it right when you seen it. NPN, fellas. That's how you could tell if it is NPN. That's how you tell. You see the positive on the L? L positive. And that one is L negative. And that one would be the load. The little box right there is the load. And that tells you that the load takes a negative on this side and a positive on this side. Easy money. So we're looking for the K1519. K1519. Oh no, that's my nail, boy. My nail's jacked up. Alright. We're looking for the K1519. Alright, I think it's over here. Let's see if we got it. We got a lot of paperwork here. K1519. There it is. So let's grab that. There it is, boys. When in doubt, grab the manual. Test it. When in doubt, grab the manual. Okay. So we got our brown wire is our positive. And our blue wire is our negative. So let's go ahead and get that done. We got our brown wire. And we got our blue wire. So what are we going to do here? So here's the question. Chat GPT it. I don't think we don't need that yet. No, the voltage is 24 volts. 24 volts. So we have to add one of these guys, boys. We're going to have to add one of these. Wiring is about to get crazy because we are transitioning from DC 24 volts. Yes, sir. Yes, sir, Carlitos. So we need to get from 24 to 120 in order to get I need to get the signal from this sensor into that PLC. How do I get the signal from this sensor into that PLC? I'm going to use the relay. So first things first, we're going to get this bad boy wired into here. It says my brown wire, which is this guy, is my positive. So that's going to go to my positive on my power supply. So let's get that done first, right? Okay, so I'm going to turn the power off because I don't want to set a bad example. If I was in the field, I would definitely have the power off to everything. You know what I mean? But we in the kitchen table, we could do whatever we want. Need some backup battery power? La fella. I got it. There it is. You see that? Lockout, tag out, right? I want to set the example, just so you guys don't make mistakes. If you guys were to try this, I'm gonna shut off the power. But yeah, there's my backup battery power right there, and we are off. We can shut this off. No power. No power. I'll even go a step further, and I'll even pull out the whip. No whip. We are good to go now, boys. So let's go ahead and set that. I just feel better about myself now. All right, boys. So now we got to get in our brown wire to our positive, right? There it is. So now, what else does it say? It says our blue wire is going to be to our negative. So let's go ahead and hit that bad boy. Yeah, I see you guys hitting that screen. Hit that screen. Hey, we should have been to 5K likes an hour ago. You guys are sleeping at the wheel. Sleeping, boys. Hey, I'm out here working, boys. I don't know about you. I'm out here working. We out here working, boys. Let's go ahead and hit that. Yes, sir. Okay, there it is. There it is. And I'm going to put a Wago on my switch leg. Now we will go ahead and I think it goes this way. Yeah, this is the way it goes. So now okay, you guys see that? So we got our switch wired in, right? All right, 5K. All right, we there, boys. That's what I was waiting for. We out here experimenting, La Fella. Yes, we are. We are experimenting on the mini strut. Yes, sir. Okay, so I got my sensor wired in. I need to get that sensor into that PLC. But the sensor is 24 volts, right? The sensor right here, that's a 24 volt signal that the sensor outputs. I'm a maintenance technician. I do this for a living. When your sensor reads, it will send the signal. Absolutely. Absolutely, Efren. Like your YouTube. Oh, you seen him, William? Thank you. I appreciate that. So we need to get that 24 volt signal into that 120 volt input side of that PLC. How are we going to convert 24 volts to 120 volts? That's the question. What device do you guys use to convert 24 volts into 120 volts? That's the question. No wrong answers. No wrong answers. I'm going to do it using... No, I'm going to do it using a relay. No, converter, contactor, contactor, almost. I'm just going to use a little relay. I'm going to have, with your relay, it will step. It is a mini transformer. So, what I'm going to do is, on a 24 volt relay with some DT, yes. So, I'm going to use the contact points of my relay that is controlled with a 24 volt coil. So I'm basically going to use it a little bit of power that controls a big amount of power, right? Like a solid state relay, yes. 24 volt coil, yes. I'm going to use that 24 volt coil to close a 120 volt circuit. That's it. It's not hard. That's it. That's it, guys. If you are ever stuck and you're like, holy crap, I got 24 volts here and I need to get this into my 120 volts. How do I do it? I'm tricking it. I'm tricking it, yes. I'm just going to use a little sensor. It's just a switch. It is just a switch. That is all it is. I'm going to use a 24 volt powered switch. That is it. It's freaking easy. Will it last? Absolutely. Absolutely it will last. That thing will kick. We use those in the field all day, every day. That's how we convert. We have PLCs that run 120 volt input signal, but we use a bunch of sensors that are 24 volts. And in order to make that conversion, you have to use the little mini relay, just like I'm going to do tonight, boys. Just like I'm going to do tonight. I want to show you guys something. Oh. I left the door open, right? You guys see it? You see that little bastard right there? Little mosquito, yo. Oh, that guy's bugging me. I know it's going to be an issue. I know it's going to be an issue. Hold up, hold up. Where's he at? Where's he at? Oh, he flew. He's flying. Oh, man. He's flying. Oh, crap, dude. Let me kill that guy, man. Let me kill that guy. Let me close this door. Got him. Freaking got him, man. Oh, my God. Got his little ass. All right. My God, man. Yes, it will last. It will last. No, but yeah, those are the kind of questions you're supposed to ask. You know why? Because you can. Feel free to ask. You know what I mean? There is a bunch of people in this live tonight that are a lot smarter than me. That's for damn sure. There is a lot of you guys that are a lot smarter than me. You just don't make videos. You know what I mean? I make videos. See, look at here. Here's the deal. Here's the deal. Here's the thing about me, okay? And I'll be absolutely honest. I know how dumb I am. And that's what puts me ahead of the game. Because I know, hey, I'm not very smart, man. I got a room temperature IQ. And I'm not afraid to say it. And I'm not afraid to admit it. I'm not going to say that I'm a freaking brainiac because I know I am not. I know it. So, if you guys are out there and you feel like you want to ask something, ask it. That's what the live is for. That's why I'm doing it. You know what I mean? But I know exactly how smart I am or how dumb I am, and that's what makes me smart. You've seen both in the field? Yeah. I'm always learning like I'm on the dumb. Yes, absolutely. Absolutely. Yes, absolutely. So I am not afraid to say that I don't know, man. You know what I mean? Saying you don't know is a lot better than burning something out. That's for sure. But I'm not saying that you guys don't know. I'm just saying all questions are welcome. If you're like, why would you do that? I got a better way of doing it. Teach me how you do it. Teach me how you do it. And if I like it, I'm going to grab it. I'm going to be like, hell yeah. Hey, the boy Jerry. Yeah, that dude Jerry on the live. That dude Marco. That, you know what I mean? He told me how to do this. Now I do it this way. I leveled up. And I'm always trying to level up, boy. We're trying to do the most here in 2026. We're trying to do the most here in 2026. All right. So I'm going to use my sensor to power my relay. And that's it. So now here's the next layer of crap that you need to know. What wire? First of all, let's figure out where our coil is on our relay. That's the next question. So we're going to use this sensor, right? We're going to use this sensor to power up this relay. But we're going to have to power up the coil of this relay. So where is the coil? Uh-oh. 24 volt coil. Right? So we're good. Our sensor is going to power our coil. And obviously here is A1 and here is A2. But guess what? It doesn't tell me any orientation. It doesn't say positive or it doesn't say negative. You say 24 volt on one side of the coil and black on the other side for NPN. Yes. So we have to remember that we're going to be wiring NPN. But I don't think NPN matters here. So we're good. So we know that our sensor is outputting a negative. It's non-polarity. You're right. You're right. See, you guys, oh man, it don't matter. You're right, Jerry. Absolutely. Yeah, you guys know already. Usually A2 is negative, if I remember correctly. That's fine, Efren. Black on the coil, any position. Yep. All right, so let's go. So I'm actually going to put this up in there, upside down. Right? That way I don't have to use a uh-oh. There we go. Okay. So now I can take my Wago off, right? I don't have to use a Wago. I can use straight up. And look, it's labeled 24 volt. Right here it's labeled 24 volt. Can you guys see that? Okay, good. We labeled 24 volt. So let's get him into one. Bam! Got it. So, my sensor's outputting a negative signal, right? So now let's get the positive signal in there. So we'll just use a little jumpy. You know what? Just for tonight, boys, I will actually use blue wire. For my 24 volts. All right. Let me make sure that this is what we got. So I'm gonna bust out the meters, right? Let me make sure because I do not want to smoke anything. I want to make sure. So let's make sure we got what we got. We're gonna plug back in and we're gonna power up because we're ready to go. Flip the switch on. Gotcha. And let's probe it out, boys. Voltage DC. We're ready to go. Yep, we're good. Wait, hold up. So there's my negative, right? Hold up. I don't want to drop that wire, boys. Okay. So that's showing that I'm backwards. Why is that showing that I'm backwards? Hold up, let me why is that showing that I'm backwards? Why is that showing that I'm backwards, fellas? Are my probes in right? Yes. Oh my God. What's going on here, fellas? So let's see. Positive, negative, positive, negative. That should be showing a positive symbol right here. There we go. No? There we go. That's it right there. Okay, good. Now can we get the same thing? We got nothing in that one. Our sensor should be lit up right now, but it is not. So I think this terminal is not working. Look at, now my sensor's lit up. Oh man, you guys catching this? Are you guys catching this? That terminal is not working, boys. What the heck? No. I got the negative and the positive. No. That terminal's working. Okay. So we only got one terminal on the negative that's working. How about that one? Oh, there we go. Okay. Okay, so we got negative, positive, positive, negative, negative. The last terminal is dead. I don't know why. Kind of confused me a little bit. You guys catching that? Maybe, no. That last terminal is dead. That last one is dead. It's the first four that are operational. No. We're good. This last one right here, no good. Positive, positive, negative, negative. Okay. So what we need to do is get this guy into the positive, right? Here, we can turn that off. Let's get him into the positive. That was tripping me out a little bit. I was like, what the heck is going on here, boys? We already had one bad sensor. This sensor is bad. We seen that earlier. It's been a long night already. It's been a long night. Bam, guys. There it is. Let's see if our relay comes on. There it is. Our relay is powered up. Our relay is powered up. It's been a long night. And we almost at 10,000 likes, boys. Shout out what happened in the back. Look at that. So our relay is powered up. So now, let's check if our sensor is sensing. Right? Oh, boys. We got sensing action. Look at that. Sensing action is going down, boys. Mike, we are wiring this proximity switch into the PLC. Yeah, we getting a full-blown circuit going here, boys. And as soon as I do that, we getting this sensor. Hold up, let me zoom out. Sorry. So we got illumination. We're lit up on our sensor. Watch this. Proximity capacitive sensor. Listen. Let me turn the motor down. Can you guys hear it? I'm wondering if you guys can hear that. You gonna bring 120 source in, correct? So, yes, sir. That's exactly what we're gonna do. That's exactly what we're gonna do, Efren. Yes, sir. Yes, contact is switching. All right, you guys hear it? Okay, good. So that's it, boys. Hold up. All right, so we almost there. We are almost there. The process source, I'm familiar with sensing metallic objects are green and cube shaped. The process sensors I'm familiar with. This is a capacitive sensor. It's a proximity sensor, but it's a capacitive proximity sensor. So now that we have our power supply, we have our relay, we have our sensor, our power supply, our sensor, and our relay. All we need is a 120-volt signal to get switched into that output. And we're rocking and rolling, boys. So now, I'm going to go by the book. Go by the book. We're going to power it down. Lockout, tag out. Lockout, tag out, boys. You know what I'm saying? Lockout, tag out. We're powered down. Switch my breaker off. You know what I'm saying? There's a few different types. Ones I work with read stainless and magnets. Yeah, a lot of people were saying the magnets. Yeah, so I have an inductive sensor right here. So this one is an inductive sensor, and this one is a capacitive sensor. Inductive reads metal, capacitive reads pretty much anything. That's why I like it. It's totally universal. You know what I mean? Shout out to you guys. 10,000 likes. Oh my God. It's every content creator's wet dream. 10,000 likes. I dreamt of this. I never thought it would happen to me. Oh, thank you. Hey, I'd like to thank everybody that made this possible, the chat, and I'd especially like to thank my PO. Thank you, PO, for letting me out of prison. I got you, girl. I got you. I'd like to thank everybody that made this possible, the chat, and my parole officer. Appreciate that. I appreciate that. All right, so let's do this. So now we need to get a 120-volt signal into input number 1, which would be our automatic function. Automatic function, right? Automatic means you set the sensor, conveyor belt running, whatever is doing this thing automatically. Hands free. You don't even have to be there. So let's do that. So we need a 120-volt source. And I'm trying to see where I can steal that from. Let's get the meter out of the way. We don't need that. Booyah, right? Got that out of the way. And we will get another wire. So let's go ahead and grab one of these guys. Ooh, I like this red one. I want to use a red. Let's use a red wire today. So whoop. Let's use the red wire. So whoop. You know what I'm saying? Okay, so we're going to plug the red wire all up into here, our source, right? Damn, this thing is getting packed. I think I'm going to have to get more terminal strips. Okay. So let me flip this back so I can see. Hold on, guys. Let me see which one is my normally open and my normally closed. So we got common. Okay, so my red wire is going to go into my common, which this is my common right here. Put that into my common.
Oh my God! Why is he so
Hold up, fellas. Technical.
so big? Oh my God!
All right, we got that into the common. And now we will put it into our normally open.
Ew, you have 4 arms! I think it's very loud. It sounds like clicking. Ew! Oh my gosh.
Okay. And now the next one is our normally open
What?
to
I can't move.
our input.
Wait, what? Wait, what? Come on! Oh!
Hold up, fellas, hold up. Ah, so hard to get in that terminal.
Oh my god.
There we go. And now we will get that into input number 1, boys. Input number 1.
Cuando llegues sobre casa y te reciban con esa mirada, dales más amor de lo humanamente posible con las fórmulas.
All right, fellas. I think we are ready to see the final product. I think that's funny because my friend was a blood and he always said, oh, you caught that? Oh, you caught that, Angel? So let's go ahead and get powered back up, right? We're going to do our lockout tag out. So whoop, booyah. We're going to power up and we go kick the power on, right? But hold up. Oh, sorry about that, guys. Sorry about that, boys. Okay. So, woo, Mike. Hey, we getting it, son. We getting it. You know what I mean? All right, let's go. So, okay, let's ain't nothing to it but to do it. Let's go. We'll see what happens. I think we're good. Let's see what happens. Oh! I thought it was going to be normally closed, so when the contact switch, it will open. So we are normally closed until we hit. So we're normally closed on the sensor and we're normally open on the relay. But we're not going to do that because right now we were operating off of the selector switch. Remember, we have 3 OR gates. We have 3 OR gates. And we had our selector switch on. So now let's do this. Boom. What is going on, boys? What is going on, boys? The show just stopped as soon as...
The spiders on are giants.
We have no inputs on the PLC. We are not inputting anything on the PLC. Let me get that light on for you, fellas. Yeah. No inputs on the PLC, right? You see that? And now let me take off of my sensor, right? Bam! Input. PLC input. Going. You see that? Yes. We have successfully wired in a proximity sensor from 24 volts to 120 volts using a power supply and a relay, boys. This is it. This is it. This is exactly what it is in the field. On the kitchen table for less than $150. Maybe about 150 bucks. For less than 150 bucks, boys, we have literally learned a wide amount of manufacturing processes. This is what makes you money. Yes, absolutely, Efren. You make contact. We are operating purely on that sensor. And the sensor state is normally closed. So you have to interrupt it for it to open to stop the setup. It went up, bro. I checked it out yesterday. The PLC cost $200. Yeah, you know why, Angel? Because they bought them up. Because they bought them up on eBay, yeah. Before I put the word out there, I've seen where it's the other way around. Yes, you, Efren, you selling kits? No, but I should start, right? Efren, you can wire normally close and normally open in so many different configurations. I made the program as well. So Efren, you can do multiple configurations. There's no wrong answer. Normally open and normally close, it depends on the application, yes. And you can do the same logic, normally open, normally close, in the PLC also. So you can have, I got a normally open, closing a normally closed that opens a normally open. You know what I mean? It could just go on and on and on with that logic. It's crazy. As long as you keep track of what you're doing, you're good. I seriously want to purchase the kit, bro. The only thing is that stopped making me was not knowing what the fuck to do. Yes. Who's that? Who's that? Angel? Angel. Look it. The price went up on eBay, okay? Hold up. Yes. By yes. True if open, true if closed. Yes. Absolutely, Efren. When we purchase, we can use it as a guide. If you can make a detailed video on the kit, so when we purchase, we can. Yes, Angel. I have some videos up right now, but the other one is the logo. Okay, now that everybody's buying them up, the prices is supply and demand, right? Okay, hold on. Let me get on camera, boys. Okay, it's I have, what do I have? 10,000 followers. So I have 10,000 followers, right? I have 10,000 followers. When I put the word out there, they got out there and they started buying. You know what I mean? They started buying. They had like 10 PLCs that were under $100 when I looked. When I looked, they had Junior. What's up, my guy? Hey, I always know when Junior shows up because he starts dropping. He starts dropping, boy. He don't waste no time. He starts getting it. Junior, shout out to you, my guy. Buenos dias, buenos noches. So you should get a pinche right. So when I put the word out there to get the PLC, hey, people started snatching it up. You know what I mean? I put an entire video out showing you guys just kind of what to put together, the little switches and stuff like that, and people started buying it up. So I guess it worked, because if you guys, I was looking at the same eBay that you were looking at. You know what I mean? So they work. So whatever. So get yourself the we'll go to eBay right now, boys. Hold up. I got another phone. We'll go to eBay right now. eBay. All right, we're gonna be on eBay. It's called the Siemens logo. No Diddy. Siemens, no Diddy. So look at, there's one that's made by Siemens. It's exactly the one that I'm using right now. Exactly. It's literally, they just put a different name on it. You know what I mean? So they're selling that one for $167. Oh, damn. When I put the video out, they were like, there was one for $59.99. When I originally looked, there was one for $40. I should have bought them up. But anyways, if I was you guys, I would get the... I would get this one. Buy this one. That's the Siemens logo. You see the buttons? They're square buttons. You guys want to buy that one. That's the one. It's 24 volt. I don't think you can find it in 120 volt, but it's 24 volt. It's all good. Use it. Had to Siemens. You do instrumentation as well? No, not really. I just do basic wiring, a maintenance department. You would be telling us to get... Hey, we could go a long way on that brand name, huh? So yeah, you guys grab that up. I know they're more expensive now. That's because everybody bought them up. So anyways, all right, guys. So back to what we was talking about, fellas. Is it the 230 RC? You can get the 230 RC. If you get the 230 RC, who's that? Angel. This one right here is exactly the 230 RC. The 230 RC is 120 volt. The other one is, I don't know the name, but that's 24 volt. It doesn't matter. Okay, hold up, boys. Look it doesn't matter what the input voltage is, or the input voltage, what the line voltage or the input voltage is. It doesn't matter. Get your hands on a module. That's it. What about IP? What is IP, Efren? Yes, Mr. Loco, thank you. Yes, get your hands on a module. No, I don't do instrumentation, Efren. Yeah, so the main thing is to get your hands on a module, and instead of using 120 volt, you'll use 24 volt. So what? You guys gotta get a power supply? Who cares? I got a power supply. Okay, so I got this guy. I got a power supply right here. I got that one right there. That's a power supply, right? And then I got this one right here. 120 to 24 volt power supply. You know what I mean? And then I got my selector switches. I have a beat up potentiometer. I am a EMS at a roller molding plant. I would love to have your insight. You are a ENS? Brandon. Okay, yeah, I don't know how I can help you. And then we got the stop, and the start. We have the selector switch, 2-position selector switch, and a mushroom head e-stop. Mushroom head. This guy doesn't know shit. You're right, Jim. Jim, is that you, Jim? JM? Chat, we need to give JM a hug. JM needs a hug, boys. JM needs a hug in the chat. That boy is suffering out there. You know what I'm saying? You know your stuff. John, I appreciate that. JM just told me I don't know shit. I think JM is struggling right now. We need to be there for a brother in need. You know what I mean? We need to be there for a brother in need. JM, this one's for you. Put a H in the chat for JM, boys. Oh, he needs a little huggy. Should he teach you not spanking those who are... Hey, it's all good, Mr. Loco. It's all good. It's all good. Yes, going on off 4 to 20. hey, chat, let's give a shout out to JM, boys. JM, this night's for you. We're going to dedicate tonight, and we're going to dedicate the next circuit for JM, because you know what? I know what it's like to hurt. I've been hurt before too, JM, and I know the feeling, and it does not feel good. Trust me, Big Rick is right here for you, my guy. I'm right here for you, JM, just like everybody else. You're why I do this. It gets better, JM, right? Yes, sir, boys. All right, fellas. So, okay. So right now we're operating off of the switch, right? Off of the sensor. I'm sorry. So now we're going to shut off the sensor. Bam. Shut down the whole operation. Shut down the whole operation, right? So now let's do our jog function. Let's say our sensor is not operational. Is our jog still functioning? Yes. Our sensor is shut off, but we can still jog the machine. Let's say it was a conveyor belt and something got jammed up in front of the sensor. Yes, wait, Mr. Local, that's right. Yep, you already know how to do it. It's fun. For me, it's fun. So let's say the machine got jammed up, right? Your conveyor is jammed. And you're like, holy crap, man, the freaking bottles got stuck in the conveyor again. I hate this place. I'm going to quit. I'm telling you, I'm going to find another job. Oh my God. I'm quitting tomorrow. You know what I mean? Hey, who's that? The whoever shot that gift was for JM. Thank you for supporting JM. Hey, thank you. I love you too, my guy. Who's that? The complaint department. Okay. Yay, way to go, JM. That's right. Hey, that one, that I love you for JM, man. The guy needs it tonight, man. You know what? It's Mother's Day. You know, I'm not even going to say nothing, but hey, I get it. I know. You know what I mean? I get it. So, set up to prevent a reverse mode. Shout out to you, complaint. So, thank you for the heart, mate, brother. He needs a hug from... Yes, he absolutely does. I appreciate you, chat. The chat has sent mad love to a brother in need. So we have the conveyor shut down right now, right? So we have the conveyor shut down. And I'm like, crap, you can't get the bottle out unless you reverse the conveyor, right? So let's say we had a selector switch, a forward and reverse selector switch. We can wire that circuit in next time. Forward and reverse selector switch, right? The conveyor was going forward and got all jammed up. And now we're here, we're jammed up. We go to reverse, bam, and we could jog it. Jogging it. Jogging it. Break up the jam and then continue with production. Get everything ready and there we go. Can you put a link in there for the entire kit whenever you get a chance? This kit was, sheesh, I put this together with literally trash, bro. This was all just random shit. Oh, I'm sorry, I didn't mean to cuss. But yes, I can do another drop on everything that's involved in here. But I just do Amazon. I will just do Amazon. So I will drop another one for you, my guy. Who said that? Who said that? Angel? Yeah, I got you, Angel. I'll do another drop. Because I updated the trainer so much since then. You know what I mean? Do you have it set up where forward and reverse will not happen well in one mode. So I do not have that, Efren. I do not have it set up. We really haven't planned for like worst case scenario, but I will do that in the logic of the PLC if I can't do it with physical components. So there's always more than one way to do it, right? Yes, but put a link so we can just click it, bro, please. I had to pause the other video. So many. Okay, I will. Okay, so okay, I'll put one, but the stuff might sell out. So the Amazon stuff might not sell out, but the eBay stuff might sell out. But you could just use the reference to go buy the one off eBay. But I'll do the links for you, my guy. I will do the links for you. Okay, I got you. So we have not set up these. We haven't got deep into the logic. Yeah, I got you, my guy. Don't even worry about it. We haven't got deep into the logic, Efren, but we will. We will get deeper and deeper. Let me learn that PLC, because there's a lot to it. There's a big ass manual. You can, but need to hardwire it. Takes two side-by-side cut. Yes, I have the forward and reverse contactors with the interlock. I have to bring them, but I haven't even got there yet. You know what I mean? I will do that. I got you. I'll do a physical, and then I'll do it in the logic as well. So anyway, so let's say we got the sensor. Bam. Let's say we don't want to operate off the sensor anymore, and we want to do like a manual jog. You could do the manual jog, right? But let's say you wanted to jog it or you wanted to run it in manual. So you would switch over another selector switch, and then you hit manual. Manual. So now we're operating purely off of that manual selector switch. It's called hand. Somebody said that in the chat earlier. Hand and auto. Hand and auto. So right now, our sensor is for our auto. Can you add a button to the VFD so it can reverse? Yes. Yes, 1000%. I can add a reverse to the VFD. Yes. I can add a reverse to the VFD. Right now I only have it wired for one direction, but I 1000% can. Still have a lot to learn. No, it sounds like you already know a lot, Efren. Absolutely. Good deal, buddy. I'm proud of you. Maintenance field pays a lot. Been doing it for 5 years. I've been doing it for 5 years too, Efren. Been doing it for 5 years. That's the thing, Efren. Our field is always growing and changing with new technology. Absolutely. Absolutely. That's why we keep up to date. And that's why I like the social medias, because it could put me in the same room as you guys. You know what I mean? There's nowhere else where I would cross your path or you would cross my path unless you came to the field and you worked with me. You know what I mean? So that's why I really like this platform, because it puts me in the same room as you at the same time. You know what I mean? And I can be like live, like on the live. You guys are saying do this, do that. I'm doing it, and then I do it my way. You know what I mean? We literally put this whole circuit together tonight. Like literally on the live, 1000%. The only thing we didn't do was change any I did change parameters in the PLC. I absolutely did. I added another input to the PLC. Originally, when we started the live, we only had 2 inputs. And now we're operating on 3. I'm a production lead, but I want to get into maintenance and learn. You better do it. Okay. Who's that? Stock market? What you want to do is you want to be extra helpful. You know what I mean? I'm just saying. Extra helpful. You know what I mean? You want to start learning how your machines operate. You want to start learning who makes the machine. What does the machine do? What is the motors? You know what I mean? How many motors does this machine have? What voltages do they operate off of? You actually need to go to school, is what you really need to do. If you have a job right now, stock market, you need to go to school. Don't worry about the money. Go to school, graduate. Okay, going to school and graduating, two different things. A lot of people go to school and don't graduate. If you go to school and you graduate, then you become extra helpful, and then you will have a really good chance in getting into that maintenance department. 1000%. 1000%. Mario, who's that? Mario Flores up in the house. Shout out to you, Mario, the crabby electrician. Yes, stock market, that's how you do it. That's what I would do. You know what I mean? So we are now operating on a manual control. Depends on the traveling. Okay, you guys are having another conversation. Okay, that is great. So we are now operating on a hand selector switch. So let's go ahead and disconnect our sensor, turn hand off, and we stay running. And that is it, fellas. That is it. That is how the sausage is made. Talk to the maintenance manager and he will put you on the right path. Yes, the maintenance manager will always put you. Okay, the maintenance manager will always put you on the right path. The maintenance guys will tell you you don't have a shot. Straight up. The maintenance guys 9 times out of 10 will tell you you don't have a shot. You know what I mean? I'm in California and the pay has to be worth it. Yes. Yes. Facts. But the maintenance manager will be like, you know what? He's using his head. The managers use their head. That's why they're in management. You know what I mean? The maintenance manager is thinking, hey, if you go to school and you graduate, I could use you. Yeah. If you graduate, I'll give you a job. That's it. That's it. The maintenance manager will tell you that exactly same thing. I talked to my manager, bro, and he gave me the Ramsey test with 32 questions. I'm sure I passed. Good stuff. Bam, right? Yeah. You go talk to the maintenance manager and you tell him, I'm about to graduate school. Can you give me a shot? I would like to stay here at the company and promote from within. And he's going to use his head and be like, you know what? I could use you. I could use you. I could use you. I got a spot on third shift that nobody wants to work. You're going to have to work third shift. But you know what? You're in the door. Once you're in the door, you are in the door. That's it. Then you come back to Big Rick's channel and you come learn with us. You know what I mean? Straight up. That's it. That's it. I have no experience at all, and that's what I told him, and he still set me down. Yes, 1000%. Hey, now that's a good story right there. I like that. I like that. Yeah, 1000%. So then he likes and sees something. Yes, 1000%. See, Jerry knows. Yeah, but so if you ask the maintenance manager, he'll always tell you have a shot. He's going to tell you the real deal. If you ask the maintenance workers, hey, you know what? That's another situation right there. Don't ask the maintenance guys. Ask the manager. 1000%. But you gotta do something first. You gotta put in work. You know what I mean? If you get into the department without going to school, a lot of people require school now. But if you get, well, that's even better. You know what I mean? But definitely, as one element of your career, you're gonna want to go to school. You're gonna want to go to school. You have the drive. Yes, yes. Maintenance worker said they referred me and never did. Angel, I told you. I love the boys, but I tell you what, man, they could be their own guys. You know what I mean? Maintenance is needed everywhere. That's why I chose the field over production. Oh, come on, man. Production's not even a question. You know what I mean? Maintenance field is so challenging. I'm talking about plumbing, welding, electrical, mechanical, just whatever your plant has, you're going to be on it. Patching walls, unclogging toilets, just everything. Networking, VND, voice and data. You know what I mean? 1000%, boys. 1000%. Thank you guys for showing up and showing out. I really appreciate it. Tonight we did troubleshooting. We did some programming. We set up 3 functions on this PLC, and we have gotten everything operational on a 3-phase motor and a frequency drive. So yes, we have put in a lot of work tonight. Very, very good. And I will see you guys on the flip side. Stay tuned for my videos and stay tuned for my other live. Angel, I'm gonna put that we'll do it again, Angel. I'm gonna put that list together, and I'll get that out on a video somehow. Okay, stay tuned. So until the next time, fellas, I will see you. Stay safe out there, boys. Stay safe out there.